Okay, so in the previous video, we learned about the different measurement tools that are commonly used in biomechanics, and we touched on some common issues that are related to these tools. Now in this video, we're going to dive a little deeper into the actual data that come from these tools. So by the end of this lecture video, we'll learn about digitization, what that means, and how that relates to biomechanics, and we'll be familiar with sampling rate or sampling frequency. So first things first, what is digitizing? Well, it comes from the Latin word digitus, which means finger or toe. And basically, they would use the width of a finger as a unit of linear measurement, which was roughly 3/4 of an inch or 2 centimeters. So keeping that origin in mind, the term to digitize means to convert to a digital format, or in other words, to convert to a number. In biomechanics, digitizing usually refers to the process of extracting coordinate data from images of movements from camera or video camera. So it's taking a picture or a video and actually assigning numbers to what is shown in that frame. Maybe you've already looked at the demo video on how the motion capture system works. And if you haven't, essentially we place these little markers on specific anatomical landmarks on your body. And that's step one. So you mark the points of interest. And then the motion capture system or the video camera, whatever equipment you're using, is recording the movement of interest. So that's step two. And then the last step, which is the most tedious one, is to actually digitize one frame at a time each of the markers on the body or each of the points of interest. And if you're filming with a video camera, then you would repeat this third step for each frame of the motion. So I just want to quickly remind you of the coordinate system that we saw in the week one lecture video. So remember, you have your X and your Y axes. And then the arrows are pointing in the direction, in the positive direction. So if you're digitizing this marker over here, then what you're doing is you're calculating the number of pixels that the marker is away from the origin in each direction. So if the origin is over here, you're trying to figure out what this marker's position is in reference to this origin or this reference point. So let's say we had just one image or one still frame from a video recording. We can see a marker that's placed right here on the right knee, and we have our X and our Y axes, which are a little bit harder to see because they're black on white with a black and gray picture. But anyways, we have our horizontal X axis and our Y vertical axis. Because of all this information, we're able to digitize the knee marker. So we're able to figure out its coordinates based on our reference frame. So we can say that the right knee in this image is positioned at 315, 465 roughly. So 315 pixels in the X direction and 465 pixels in the Y direction. So that's the position of the knee marker in that specific point in time in that exact image. Now, what if instead of just a static image or one picture, you want to digitize a whole video? So as you can see here, the markers on the legs are moving as the person moves through their jump. So the position of each marker will have a different value, a different XY coordinate, depending on what point of the video you're looking at. So in this case, you need to remember part of step 3, which was to digitize each frame of the motion separately. So you'll have an XY coordinate for each of the markers for each frame of the video recording. So hopefully you can imagine how many numbers you end up with. Digitizing is no joke. So this idea of having a bunch of different frames in a video recording leads us to learning about the sampling rate. When you're digitizing, remember that you're converting something to a number. Another way to think of that is to say that you're taking an analog signal and you're converting it to a digital signal. We can think of an analog signal as just simply this time varying signal. The length of time of the signal can change, and really the difference between a digital signal and an analog signal is that a digital signal is measured at these discrete intervals. So the numbers that you're associating to the motion are only true for a specific point in time for that signal. And that's what a discrete interval means. So then a sampling rate, which is also known as a sampling frequency, is this interval at which an analog signal is measured in order to convert it to a digital signal. And don't worry, we'll make sense of this in the next few slides. Another way to think of sampling rate is as a measure of the number of frames that are collected per second. So that's the unit of measurement. It's a shorter way of saying frames per second is hertz. So that's the HZ here. It stands for hertz, and that's really the unit of measurement of a sampling rate. But what it means is number of frames collected per second. So if you see that a camera is collecting a signal at a sampling rate of 100 hertz, that means that that camera is collecting 100 frames of data per second. So another way to think of that is in 1 second of time, there will be 100 frames to digitize. Okay, so you may be wondering why sampling rate even matters. Well, hopefully I can show you why in the next few slides. So let's look at this graph first. We have these two positions, or these two data points, between seconds 1 and 2. So that means that our sampling rate in this case is 2 hertz, right? We have 2 frames in 1 second of time, or 2 frames per second. Now, if you're trying to think of what that might mean in terms of position and how someone moved throughout that second, you'd be tempted to just draw this straight line going from point A to point B because you don't have any other information about the position. But what if now, in that same 1 second interval, we have 3 data points, so our sampling rate increases to 3 hertz. So the motion is not at all the same, right? Before it was just this straight line from this pink dot to this pink dot, but now we have this extra information here, whereas halfway through that second of time, there's this position way up here. So now with a higher sampling rate, we have more information about the motion, and we're not tempted to make that same conclusion. We now think that the motion is to go up to this position and then back down in that same interval of time. So increasing the sampling rate to 3 hertz allowed us to see this peak in the motion at the very top, but it was still quite choppy, just 2 straight lines. If we now increase our sampling rate to 7 hertz, or 7 frames per second, look at how much more detailed the motion is. So we can describe the motion a lot better with this higher sampling rate than when we first started with just these 2 pink data points, right? We have the same interval of time. We're still just looking at the change in position from second 1 to second 2, but the higher the sampling rate, the more information we have about the position. Okay, so in this lecture video, we learned about digitization, what that means, and how it relates to biomechanics, how we're able to take these pictures, these videos, and turn them into numbers. And we also learned about sampling rate or sampling frequency and how that might affect our interpretation of motion or movement.